So let's just practice doing a few. So if we have these functions here, and we have, those are the derivatives. We've done the derivative, okay? We've done that. And now we want to go backwards. So this first one here, so what would happen? Well, in the rules of derivatives, when you take a derivative, you multiply by the power, and then the power goes down by 1. So here, we would divide by the power, and the power would go up by 1. And then we have to have a generic little constant there, because if we had a constant there, you need a little placeholder. Now, you can write that easier, and that's x cubed plus c. Now, how can you check it? Well, the derivative of an antiderivative should be the original function. Let me say that again. A derivative of an antiderivative should be the function that you started with. So if I take the derivative of x cubed, that's the way to check to see if I am right. That is 3x squared, which is little f. Now please use the same notation. The capital would be your antiderivative, lowercase would be your original function. Let's do it again. So how could you get 1 over x? Well, there is a derivative that we got to remember. The derivative of the natural log is a 1 over x. So we must have started out with our function being a natural log, because the way that we can check it is if we take the derivative we should get the original function. Well, the derivative of natural log of x is 1 over x. And then put a c there for the constant that could have been there. We don't know. So it's kind of like just a family of functions that could result in that particular derivative. Okay, let's keep going. How could we reverse a cosine? Well, whose derivative is a cosine? Well, we know that the derivative of a sine is a cosine. And how can we check? Well, I'll take the derivative. We better get the f of x, which we do. Perfect. And then finally, which function's derivative is e to the x? E to the x, but there could have been a constant there. And you can check it. The derivative of e to x is e to the x. Derivative constant is 0. That's why the constant's there. It could have been plus 2, plus 7, plus 1/2, plus 1,000,000. Who knows?